Hello and welcome to Module 2. In Module 2, we're going to take a look at what is data. We're going to learn how you can identify the type of data you're working with, or should I say the type that Python believes you're working with, and what you can do to work with that data. We will talk about using something called operators and how operators work on different types of data in different ways. We'll also talk about how the programming environments will identify data as either a value type or reference type and perform actions differently depending on that determination. In addition, we'll introduce the concept of an integrated development environment and kind of get you started on one of the integrated development environments that I like called PyCharm. Once again, as usual, there's lots to cover, so let's get started. Let's look at the nature of data. So data is information stored. The idea is that it'll either be stored temporarily in the computer's memory or persistently on some kind of medium. Now the medium in pre-computer age was usually paper, and that's where you store the data. But of course now it's going to be some kind of hard drive, or maybe a hard drive on somebody else's computer in the cloud or on your network. So some kind of drive is going to either store the data or you're going to store it in memory. And if you store it on a drive, it'll persist between shutting down the power and restarting it. If you store it in memory, it won't. As soon as you lose the power, the data stored in memory disappears. Now, when you work with data, you do so in memory. This means that if the data was stored on a drive someplace persistently, it would have to be pulled up out of the drive or off the drive into memory, and then you work with it. You do particular operations to that data. And then once you're done manipulating the data, you have the option of either saving it back in onto the persistent data storage unit, in other words, a drive, or you can just let the changes disappear. So either you save your work or you don't. That's pretty much it. And that is the nature of data. The data is what you stored, but what you get out of the stored data is information. The idea is that you store it on a drive, and then when you pull it to memory and you as a human review it, you extract information out of that data. Now computers will sometimes have applications that will store the data persistently and other times not. For example, I'm using Word here to type in my notes. In that case, I save a Word file onto my hard drive, and that's persistent. But another example would be using something like the Windows calculator, in which case I type in the calculation, and as soon as I close down that calculator, it just disappears. Again, both are perfectly fine to use, and there's no right or wrong way to do it. It's just a matter of preference, which one do you want to use. Now, in addition to making a decision about whether you want data persistent or just transitory, you can also decide what type of data you should use, how much data storage is needed. Back in the old days, we had to be very explicit about how much storage you want to set aside in the computer's memory and load it up off the drive into memory in that defined space. To make things easier, we identified different types of data, gave them names and specific sizes so that they could be stored in memory based on the name. It's much easier for humans. So you could say that a piece of data would be a decimal value or an integer value, something without a decimal point. And if that was the case, then the size for the integer, which didn't need any additional space to track how many numbers after a decimal point, would be smaller than the size of a number with a decimal value, because you needed to identify how many values after the decimal point. We also came up with other data types such as a string of characters, an individual character and then a string of characters together. We just usually call them a string. And that would be a different size altogether. So now when you indicate that the data you want to store is a character or a string or an integer or decimal value, or there's other designations too. Popular ones are dates. It would automatically identify how much space you need to store these values so you don't have to go and micromanage it. Now, in the industry, there's a bunch of different sizes, and everybody that builds their computer language can choose their own size for like an integer. Typically, an integer is going to be 4 bytes, but back in the earlier days of computers, it was 2 bytes because, well, we didn't have that much memory space, RAM. Nowadays, you may have a larger integer, and often, because just having a single data type was not very efficient, you may have things like a small integer, which may be 2 bytes, an integer, 4 bytes, a large integer, 8 bytes, or something else. Every language is a little bit different, and when you learn a programming language, you kind of have to identify what are your options so you can choose that. So that's the nature of data, and what you do in a program is you manage the data by telling the computer what you want to store, and you let it handle where it's going to be stored. And you have to be kind of somewhat careful, because if it thinks you are storing an integer, and then you try to put in something like a decimal point value in it, you'll get an error message. Some systems will automatically adjust and switch it from an integer to a decimal point, and other systems, once you defined it, it can't. It can't change. Python, as you might suspect, is very fluid, very friendly, and as such, it automatically adjusts things. But you still have to kind of understand that automated change of the data so you can kind of prepare for any ramifications that come up from it. So that's the nature of data. Let's talk about what you do with that data. To input the data, to store it, you gather it from the human. You can do that with the input function command. To present it from data in memory to the human, you will use the print command. That's the most common way to do it. There are other ways to do it too, but certainly the print and input are the two most common ways to input and output data with the user. Those are the tools that we're primarily going to use throughout the course. I mean, they're just the common tools that you use all the time. They're pretty easy to do. So print, you put a parenthesis, you put a couple quotes, either double or single quotes, you put the text you want to output to the user. And input, you can just call the input function. When the user types in input, it'll be captured in this thing called a variable. And we're going to talk about that next. To store data, you need to identify a place for it to go to. And that comes in 2 basic flavors. Your 2 options are you can declare a constant and store data in a constant, or declare a variable and to store data in a variable. And the difference is that if you store data in a constant, once it's set, you don't change it while the program's running. If you store it in a variable, it can vary as the program runs. Now, if you stop running the program, you can always change the value and then run it again. But if you want that value to never change while the program's running, put it in a constant. You don't use that as often as variables, because often you do want to be able to manipulate the data while it's running. But those are your options. Now, to declare a constant, it changes per language. I've given you 3 examples right here. This first example is in C#, where you put in the word integer or string or something like that. It's not actually the full word, just 3 letters is fine. That's typical, by the way. And then you make up a name for the variable. It can be anything you want. In my school, I think most people in America, that we used X, Y, and Z as examples of variable names in math. I'm just using the same thing here. So I'd say integer x, indicating that I want a integer variable, and put in whatever name I made up for the variable name, and then a semicolon in C# to indicate I'm done with that command. I'm done with that statement. If I was using the structured query language or SQL language for databases, it'd be similar, but things are kind of reversed. So you put the name of the variable first, and then you put the data type after. And those the SQL language, you also use a semicolon to indicate I'm done with that statement. Now in Python, they've made things easier. It's really kind of a theme with Python to make things easier. So we would just put the variable name, and that's it. You don't have to tell it what type of data you're putting in there. You don't have to indicate that I'm done with the statement. Actually, if you hit the carriage return at the end of your statement, it assumes that you're done with that one and we're moving on to another one. Semicolons can be used, but they're optional. Anyway, how it determines what data is in there is going to be, like what data type is going to be in there. It is determined at the time you put the value in. Right now, I've declared 3 variables, one in C#, one in SQL, and one in Python, but I haven't actually put any values in. I haven't put any initial values in. Now, as I said, if you declare a constant, it's similar, but the difference is you have to put a value in at the time you declare it. Again, let me use an example from C#, because Python is a little bit odd. They don't really have a clearly defined constant option. It's more of an honor system. Once you define something as a constant, in other words, I'm using air quotes because it's up to you to kind of to indicate that this is a constant, and it's up to other people using your code or using your program or modifying it later on to honor your wishes. But in other languages, you clearly define that the data is going to be a constant. For example, in C#, you type in these 5 letters. So constant, integer, data type, and then the name. And by convention, in the industry, we usually will declare the variable, the constant's name in all uppercase letters. That is a standard in the industry, but it is up to you. I would say, though, that that's a great standard to continue with, because you'll see it in many languages. I don't know of any language that isn't a representation for a constant value. And again, you have to actually give it a value at that time. So when you declare it, you need to give it a value. Like I've given a simple, version of the number pi and called it simple pi. On Python, I can do the same thing. I can make it uppercase, and I can put it a value. I can set a value, an initial value immediately. And the fact that it's an uppercase represents to other people looking at my code or maybe modifying my code that I intended that to be a constant. But there's no safeguard built in. So if somebody hundreds of lines later or 5 lines later or 2 lines later change the value of that variable, well, it's not really a constant. It's just a variable I want it to be a constant. That's just the way it is. Now, variables in Python, like I said, you can just give it a name and you're done. However, to tell you the truth, most of the time what you do is when you give it a name, you set an initial value. So I'd say x is equal to 5 or x is equal to 10. And if this is the first time in my script that I've typed out x is equal to 5, I've declared the variable x and set an initial value of 5. So I've initialized that variable. If on another line, like in this case, the next line down, I've said that x is equal to 10, well, I've already declared it, so I'm not declaring it again. I'm assigning the value of 10 to x. So this means that this equal sign is used to initialize the value of 5 as well as set the value of 5. So I'm using it for both people. And I don't know, initialization, kind of fancy term, it's just saying I'm setting the value for the initial time. That's all. Remember that in Python and in other languages too, the idea of a constant is that once you set the value, you don't change it. It's just that in Python, you have to, as a human, enforce that mentally. You have to decide that you're looking at code and say, oh, whoever wrote this program, maybe it was yourself or somebody else, did not intend that to be changed. As I just mentioned, we use the equal sign to assign values to variables and constants. Now, one thing that can be a little confusing to beginners is the way we do it, the order that we do things in. Now, the reason why I think it's confusing is because when we were young, most of us learned to write out an equation like this, where we said 4 plus 5 equals 9. And that was the answer that our teachers were looking for. Later on, as we got a little bit older, they kind of blew our mind, so to speak, by showing us that you could do the same thing like this. 9 is equal to 4 plus 5. And in fact, if you had a question mark here, this the idea was to solve this equation, you would have to figure out that 9 would go in here. And that was one of the things we learned. Now, 9, of course, the question mark basically was a variable that you were using. And in the later stages of math, or advanced algebraic math that we learned, we would see the use of these variables. Now, that's the way people kind of learned in America anyway. Most people I know learned it that way, in that particular order. But the correct way to write it in programming is always like this, where the variable goes on the left-hand side, never on the right-hand side. That's important. The reason why it's important, because when people type out their code, let's say I'm assigning a value of 5 to x and I'm assigning the value of 10 to y, when they type out code that looks like this, y or x is assigned the value of y, you have to know that it always goes from right to left. Always. In programming, it's always going to go from right to left. So that means if y was the value of 10, we take the value of 10 and we assign it to x. When we print out x on the next line of code, print x, it's going to print out 10. That's because the value of 10 from y has been assigned to x. And if it was going the other way, then from right to left, or excuse me, left to right, then what we'd see is that the value of 5 would print out. And we don't see that. What we always see is the value of 10 is going to print out. An important concept, especially for beginners, because they may have learned the other way earlier in life, and often what you learn earlier in life is the one that kind of sticks in your brain. Why don't you take a minute to kind of practice this in a simple little lab. Basically take this code. Let's see, it says from listing 4. Oh, I don't think so. I think that's listing 5. Let me update that. From listing 5, and type that in and see if it works. Go ahead and pause the video now and give it a shot. Once you have that done, go ahead and write out what it does. So you should have opened the idle and typed out this code. You could type it out in the interactive mode, but what I really wanted you to do was to type it out like this. Make a new file. And since I'm making a new file, I think what I'd do is I'd go ahead and save it. So save it and give it a name. Let's put it in a good location. I'm going to go ahead and put it in my Python class folder. We're in Mod02, so I'll go Mod2. And I'll call it, let's call it Lab 2-1, just to match the lab we're doing. Okay, now you don't have to put in the py extension, it'll take care of that for you. Now we just type in the code. Run the module. Yes, print out 10. Now, a couple things that you may have written down. It did work this way. You also may have written down and made a note that you don't actually have to have the semicolons. If you run it without the semicolons, it still works. remember that they are optional in Python. And if you were to switch the order, you were to say y equals x, you could prove, let's just do this actually. Let's go ahead and make another print statement. That it works as we said. As I said, it will always assign the value of x to y in this case, because it always goes from right to left. So that's it. Like I said, it's a very simple lab, but hopefully you notice those kind of key features. Well, a computer sees data that you store as just ones and zeros, whether it's sound or integers or video or whatever. Humans definitely see a distinction between these things. And certainly the way we use them is different as well. So when we want to add two strings of characters like first name and last name together to create a full name, that's different than what we want to have happen when we're trying to add two numbers together. So for the computer, we need to identify how we want the computer to understand, interpret, and use the data we store. And this is done by indicating its data type, its type of data. So, like I said, the computer sees it all as ones and zeros, but if you identify the data type, then you can also identify how you want it to process the data when you perform certain activities, like adding things together. Now, when I'm working with a computer, I need to sometimes force the distinction between types of data. So, for example, I don't want to take an integer of 4 and try to add it to the last name of Smith. Those are considered two different things. One's an integer, one's a string of characters. So I definitely want to identify what the difference is. And if I try to do something like that, I want to be able to get an error message indicating that I'm doing something that's incompatible with my desire about how this data should be stored and used. In many languages, what you do is you indicate exactly what type of data you want to store, and then if you try to violate that, so if I say that I'm going to store x as an integer, and I try to put in character data in there, I would get an error message. In Python, however, it's much more friendly and automatic. It just adjusts, and you have to be careful of that. So in Python, they decided that to make it automatic would be a better choice, and the value that you put in the variable determines what type of data is being stored. And if you put a different type of value in there, it would automatically adjust and convert it over to a different data type. It's still using a data type. It's still identifying the type of data being stored. It's just doing so automatically. And this description of what type of data something is stored in the computer's memory. So this is part of the programming environment that you're running your code in. It's identifying the name and the type and the size of the space needed to store your data. So name and type and size are the key things that are being used to identify what your data is and how it is to be stored and used. Now, the classic built-in data types that you'll see in languages, and in Python too, of course, is a string of individual characters, so just called a string, an integer, value without any decimal point, a float, or decimal, or numeric, or there's other names to it, but a float is a type of decimal where you have some kind of value, integer value, plus a decimal value. And then the other one that's really common is Boolean. So in Python, we have string and integers and floats and Booleans. Those are the common ones that we use in the Python language and in other languages as well. Now, in most other languages, there's also going to be additional ones that are kind of specialized. The most common one you'll see out there is a date for storing date values. Dates are important because the way we calculate a date when we convert it over to ones and zeros, can be a little complex. But if you approach any language, and certainly as we get started with the Python language, we're going to focus on the strings and integers, floating point values, decimal values, and Boolean values. Some things to keep in mind is that when you enter a new value into the variable, the old value is lost. So it does retain the change over time. So if x starts off at 5 and it changes over to 10 later on, the old value is gone. So it doesn't retain that. When you choose a data type, when you personally choose a data type instead of letting something Python's automatic mode kick in, then you want to be very specific about what your desires are and use common sense in choosing it. So for example, if I know that I'm going to be capturing the user's first name and last name, I don't want to make it an integer. I don't want to identify the variable as being an integer. Common sense. And the most common data types you're going to use in programming languages are integers and floating point numbers and strings of characters. You don't use Booleans as much. Those three are the ones that you work with constantly. Since Python automatically identifies the type of data from your value and sets its data type accordingly, it's nice to be able to find out what type it chose. Remember, it's automated. So you can usually guess what it's going to be. For example, if I make a variable called integer first name. Now, the prefix here, that's just my personal notation. I want to indicate that I'm storing an integer. But that doesn't stop Python from putting anything in there at once. For example, let's say I were to take this code, copy it, come over to idle, paste it in, and then run it. What would happen is that when it ran, I would, on this line here, I would get integer, class integer. Class stands for classification. So the classification of that data is, it is an integer made from a value, an object made from the integer class. Anyway, so it's indicating that that's the type of data is being stored in this variable. Now, I put the prefix on there myself when I just made up the name. I put that on there because I want to indicate that my intention was, I want you to store an integer. But that doesn't stop me from changing the value and putting in something like 5.8. When I do that, what's going to occur is that it's going to change the data type automatically to float. Notice that my naming convention doesn't change. So the downside of my little naming convention is that if you do change the type of data in there, then it's not really going to represent what's being stored. However, I got to tell you, in practice, usually when you're programming, you usually want to set the value at a certain data type and not change from that. So for example, if I make up a first number and a second number and I'm going to use them to add or multiply them together, I can choose between an integer or a float, but once I've made that choice, I'm probably not going to change that in that one program. I intended it to either be an integer, in this case an integer, and I want to stick with that in that one application, that one script, that one program. So what I usually do is I put in here like FLT for float, if that's what my intent was. Notice that now these two variables are very different. They're two different names. And they indicate that I want to store a floating point value versus an integer value. But do note that if I were to just leave the name as it is and put in double quotes around the 5, it would now become a string. Or put in the word true, uppercase T, it would now become a Boolean value. It just automatically adjusts in Python. And that's kind of convenient, but it's also can be a little bit of a pain when you're trying to troubleshoot things. As we'll see as we go through the course, sometimes identifying what type of data you're working with is really important. It's going to be best to kind of see it in life, in real life, as you're practicing and you're studying and things. But right now let's go ahead and pause the video and try this code out. So the next lab is type in the code. You can copy and paste that, that code into an idle window and make it run, but my recommendation is take the time to just pause the video and type it out and try it. Once you've done that, once again, just write down a quick note about what it does and why it does it. And then come back and we'll continue on. Let's change the subject and talk about escape characters. Our escape character is a way of telling the computer that you would like to change the behavior of a symbol or character. So for example, the behavior of a backslash or a single quote or a double quote may need, or T may need to be changed. So let me just give you an example. So let's say I have some text. It's not any that fancy, and I put a T in there and I run it. The normal behavior of the letter T is to print out T. But if I put a backslash in there, now it changes the behavior of that letter so that it's interpreted as a tab. So there's an alternate interpretation of a character or symbol. In this case, it's the character T. Another character we use all the time is N for a new line. Notice that it puts it on another line. But it also works with some symbols. So you can see that I've got double quotes here. And if I were to put in double quotes here, it would have a problem with that. And because it thinks that I'm ending the quoted string of characters right after the space, so a space, and that's the end of the string. And then I've got this end just floating there with nothing around it, so doesn't know how to interpret that. Followed by another set of double quotes with the B inside of that. So it's confused about what I'm trying to tell it. And how I would escape these double quotes to be interpreted not as the end of a string or the beginning of a string. I'd want them just to be the character double quote printed out would be to escape them. Escape their normal behavior to an alternative behavior. In this case, it would be printing out the value. Watch. See how it actually just interpreted that as the character double quote instead of actually saying this is the beginning or the end of a string. So there's a few of these that exist. Some of them will not be immediately useful to you. The one that probably is the double quote or escaping a single quote. Those are sometimes useful. So if I'm using single quote here instead of double quotes, it does the same thing. The tab one's kind of immediately useful to you if you want to tab in your code or in your output. That's useful. But some of the other ones you won't notice until we start getting into later modules. For example, the use of the two backslashes, which seems kind of weird. It looks like it doesn't do anything. But if I put a second one in there, basically the second one is ignored. And we'll see that later on when we start working with files in more detail. The other one that's kind of weird is the /n for a new line. That one actually works pretty well most of the time, but the /r, which is for a carriage return, doesn't always work the way you would expect it. And in some programs, what we often see is people do a combination of /n and /r in combination. And that comes from back in the days when we used a typewriter. Now notice that when I just had /n, it did the same thing as when I did /n/r in idle. Let me go back to my statement. This is what we used to use on typewriters. We would be typing along, and then the carriage, which would hold our paper, would move. And when it got to the end of a run, we'd have to return the carriage back to its original location to start the next line. When we returned it, it would be on the same line. So what we'd have to do is we have to roll a little wheel to move it to the next line. Sounds kind of painful, doesn't it? That's the way it was. Later on, we had some automation included so that when it reached the end of the line, it would automatically return and give us a new line. That was a great automation. And we still see that notation in computer programming, even though we're not using a physical carriage and we're not using a typewriter. Still, you just need to know that the /n and /r can be used in combination or alone, and it's going to determine the way things present to the user. Depending on the operating system, depending on the application that is running your code, you may see different results. So it's up to you to always test. This is one of the ones that are kind of a gotcha. You always have to test to make sure your code looks right, or excuse me, your output looks right when you use /n and /r. Don't stress about it. What will happen is that over time you'll get the hang of it, just like using the backslash, the double backslash, or the \t. It'll become second nature. So don't worry too much about it. But as we go through the course, keep your eyes open for opportunities where the escape character might be used so you can get a chance to learn it and understand it. Another use for the backslash is to indicate that your code continues on another line. What I mean by that is that the statement that you're typing in should be considered a single statement, even if it shows up on multiple lines. Let me just give you a demonstration. So I've got idle open here, and I'm just going to type in a print command. And I'll put a very long string of characters I want to print. So that's a long string of characters. It actually runs off the video there. I want to actually make this more vertical, so what I'm going to do is I'm going to do this. And now it's a little bit shorter. So where is it? If it was on a single line, it would be cut off. But if it's on a second line, it is not. Now, when the code runs in idle like this, you would think it would work, but you notice that it does not. It actually doesn't print out anything. I can use a backslash to indicate that I really meant this to be interpreted as a single statement. And when I do that, it works. You can also use it inside of a string. So if I go ahead and break the string like that with a little invisible carriage return, I can use the backslash to indicate that that string continues. See how it's still considered a single line of text? So this is a line continuation character. This means that the backslash is being used in a couple different ways. It can be used to indicate that we're continuing a line of code, or it can be used to escape a character, meaning that this symbol, this operator, this fancy term for it, has been overloaded. It has multiple versions of itself, multiple meanings. And what happens is that the computer looks at the context and decides what you mean by it. So for example, if I put a T after the slash, notice that it's unhappy with me now because the T is being interpreted as a tab, not as a line continuation character. So it takes a look at the combination of how it's used and what it's used with to determine the way it's going to run. This is called overloading. So that operator, the slash, is overloaded. In addition to overloaded operators, we have overloaded functions. So the print function is an example of a function that's overloaded. It just means that it has multiple versions of itself. So for example, if you consider this code, and I run it, let me close that down. It gets too busy otherwise. Okay. Notice that the way this worked was, first of all, print it test, and then when it said print test times 2, it print out test twice. Now this means that originally I had a string of characters, but on the second time I ran the print statement, it had a string of characters plus the multiplication symbol plus an integer value. That's very different input coming into print. And as such, the different input causes a different output. If I go print test, comma, message, it prints out test message. It does so with a space between the two because of a default behavior of the function. The default behavior of the function is, unless you tell it otherwise, it will put a space in between the options that you pass in. Notice I can use a combination of things. Once again, that's a very different command than the previous one, and as such it prints things differently. Now in version 3 you will see a couple other ways you can kind of modify this. For example, I can indicate what type of separator I want. So instead of having the space be my separator, I could indicate that I want a dash. So now when I say print test, comma, message, I can have a dash in between as a separator. In addition to that, you can also have an ending to your string. By default, the ending is a carriage return or a new line. So by default, I've got new lines of text, but notice that if I indicate that the end should be a colon instead, when I print out the next string of characters, there won't be the default carriage return. Instead they'll use a colon. So I'm changing the way the function behaves by passing in things, different things. And basically what happens is that there's multiple versions of print, and it interprets what you pass in to the function. These are called arguments. What arguments are being passed into the function, and performs something slightly different depending on the number of arguments and the type of argument values you pass in. Now, Python has documented this information in the help files, and the help files are great. They're actually pretty decent in this language. Some languages not so much. However, I have to tell you, they're pretty technical, so sometimes if you want to find out what your options are, the help files aren't always the best. It's not a bad place to go once you really kind of know what you're doing, but a lot of times you just have to, especially when you first get started, just go ahead and try things out. Try putting things in, see what happens. Looking up on the internet, looking at less technical, I should say, sites to find out what your options are. And then what I find useful in the help documents is that they will give me a quick reminder of something. A couple things to note about help files is that you'll see notation very similar to this, where you have square brackets indicating an optional bit of code. Now when I see this instruction from the help files, this is a copy and paste from Python's help files, excuse me. What it says is optionally I can put some kind of object in there. Now it says object, not a string of text, so I could try a different type of object like an integer and see if it works. And it does. I could try in a Boolean, a floating point value, and see if it works. And that does too. So that's why they're using the word object. And because it's in square brackets, I assume that that means it's optional. I don't have to have anything in there, and that's true as well. The separator is optional. If you don't put a separator notation in there indicating what your wishes are, it'll use the default of a space. That's a little space right there. Or if you don't indicate what you want the end character to be, it'll use the default of a new line. There's also this one for standard output going to for a file, but let's not talk about that right now. So, like I said, this is kind of a very technical description of what's going on. And a lot of times you'll find something a little bit simpler and kind of easier to read other places. But in the end, a lot of it is just learning, is just kind of trying things out, not being afraid to try it out and see what happens. So why don't you do that now? Go ahead and see if you can get your code. Go ahead and open up idle and type in some code in this lab. Make a new script and see if you can get this output to perform like shown here. This is the output we're looking for. The code inside of the previous listing is what you want to use. Go ahead and stop the video, type it out, test it, and then of course, as always, write down what your thoughts are. I've used the term operator a few times now. What an operator is a symbol or set of symbols that perform some kind of functionality. In many cases, basically what an operator is a function represented by one or more symbols. So we can see a plus sign, and that plus sign can be used to add two numbers together. We could have made a function called add and put in a first number and a second number as an argument and add them together. However, it may be a little bit easier to read as a human if we were to just use a operator between the 4 and a 5 value, come up with a value of 9. Now, there's lots of these operators built into languages. In most of them, the plus symbol does indeed add numbers together, but it also has the property of adding strings of characters together, strings together. So, for example, if I were to look at code like this, one long string of characters, using a plus sign, notice that there's a space here, it would add those up together. Well, actually not add per se, but concatenate. So they would be one long string of characters, a single string of output that I would print out. Again, we could have used methods to perform these kind of actions, like an add method, and pass in some arguments. But it is easier to read for many humans just to put in x plus y equals something. In this case, 5 and 4, x plus y equals 9. So the plus symbol in this example is an operator, but so is the equal sign. That's the assignment operator. It's assigning the value of 9 to the variable sum. If it's been a while since you worked with these terms, you might want to reflect on the terms operands and operator. So the operator are the symbols, the operands are the things that are the operator is working with. So 5 and 4, there was two operands working with the operator of plus. And the operator of plus is actually using the additive functionality. It's adding numbers together because it finds numbers on either the left, on the left and the right, not either, but on both sides. If, on the other hand, it found character data on the left and the right, it would combine them together by concatenation. So the operator uses the type of operands to determine what type of functionality it should have. Once again, if I come over here and just kind of demonstrate it, if I put in a 4 plus a 5 and ask it to print, we'll see that it does indeed print 9. But if I put in a and a B, it just concatenates those two and prints out A and B. Now, one thing to note is that sometimes there's no version of the operator that will accept the operands that you're trying to use with it. In this case, I'm trying to use a character A along with an integer value of 5. If nobody wrote a version of that operator, a overload of that operator that had a character on one side and an integer on the other, you're going to get an error message. What it tried to do was it tried to concatenate the string to the integer and gave me an error message. You can only concatenate string, not integer, to string. Pretty clear error message, but that's what's going on here. There was no version where the operands could be integer in character or string. And once again, there's lots of these operators. Most of the time, they use two operands. Sometimes they use a single operand, and sometimes they use three. So an example of an operator that uses a single operand would be like this, where I put a -5 there. And now the negative is a symbol, it's an operator, but it's making this a negative value. If I go over here and I put in a 4, you can see that I get the negative value. So it's actually running this to equate this as a -5, and then taking that -5 and adding it to +4. If I did this, let's see what we get. Still the same, because if you don't indicate whether it's positive or negative, it's going to assume it's a positive value that you're looking at, not a negative one. So this is an operator, but it has a single operand, making it what's known as a unary operator. This symbol here, the negative, is also a unary operator, because it only has a single operand. But the plus symbol here in the middle, that is a binary operator, because it needs two operands to perform its function. As I said, you will find sometimes there are some cases where there's a trinary operator, in which case it requires 3 operands. So you don't have to really worry about this. Just realize that there are times where the functionality is determined by what operands are given to the operator, what data type is each operand, and whether or not that operand is being passed in 1 or 2 or sometimes 3 operators or operands. Messing things up. Now do be aware that the equal sign in the example I had up above, that is also an operator, in which case it has the operand of the variable on one side, or constant, and the expression or value on the other side. And then it assigns the value of the expression to the variable or constant, sum. So that is designed to take 2 operands, making it a binary operator. Also, as I said, sometimes the operators have more than one symbol. So in many of the C-style languages, like C++, C, Java, you can put 2 pluses right next to each other. Collectively, that's a single operator with a single operand. And what this would do would be to add 1 to the value of 4. So that'd be, it's currently 4, plus would be add 1. Sometimes you'll see it at the beginning, and sometimes you'll see it at the end. But it's the 2 symbols are being used for a single operator. Now, in Python, it doesn't give me an error message, but I'm not seeing any advantage of doing that. So this is something that you see in the C-style languages, but I'm not really seeing anything there. Let me set a variable. I notice we got an error message when I put them at the end. You can see that, once again, it's still 4, even though I told it to bump it up. Let me, to bump it up by 1, that's what the plus means. And we'll print it again down here and try it one more time. If I was using a C-style language, what I would see was that it would go up from 4 to 5, because it would bump it up by 1. So Python doesn't use that, but it does have a lot of other operators that get used in many programming languages. For example, if I want to change the order of operation, I can use parentheses. So with a parenthesis, or should I say with parentheses, I can change the natural order of operation. By default, if I were to take out the parentheses, it would multiply 4 times 2 first, and then add 2 to it. So I'd get the value of 10. But if I use parentheses, it will perform the addition first, and then multiply that by 14, give me a value of 16. Now that means that there are 2 symbols here being used, the starting parenthesis and the ending parenthesis, and then some kind of expression in between. So I've got some kind of expression I'm including between the 2 different parentheses. The parentheses themselves, the 2 symbols make up a single operator called the precedence operator. The precedence operator is overloaded as our parentheses operator, I guess I should call it, because it's in this particular case is used for precedence. But the parentheses operator itself can be used differently depending on what kind of arguments you pass in. Notice that in this case it's a single value that is formed from the expression. But in this particular case, there is a string, comma, and another string. So I have multiple values in between the parentheses, and I'm not performing some kind of addition. In this particular case, what I'm doing is I'm setting up a collection of data in what's known as a tuple. A tuple, fancy word for a set of values or an array of values. Anyway, so what this shows is that the parenthesis operator can be used multiple different ways, meaning it's overloaded. We say that a lot in the computer industry. We see a lot of these operators that get reused for different things depending on what type of operands you have. Another one that we use on a pretty regular basis is square brackets. Square brackets are used to indicate another type of set. This type of set is known as a list. And with this set or array of values, it's a little bit more flexible. We're going to take a look at both of these a little bit later. In the first example, I used a tuple, not as flexible. In the second example, I used a list, more flexible. And what I mean by flexibility is the different options you have when you use them. Another operator, which is actually using a keyword instead of a set of symbols, which that doesn't happen as often as the symbols, is the negation operator, or not. So when I use the word not in front of something, it changes the validity of an expression from true to false or from false to true. So for example, if I were to set x equal to 1 and then ask the question, is it true that x is equal to 1? That would be true, but if I use not, it changes the true to false. So it's called the negation operator. Notice that there's another operator here I'm talking about. This is the equity operator. The equity operator is different than the assignment operator. The assignment operator is a single equal sign that assigns a value from the right to the left. The equity operator compares the values and indicates whether something is truly equal to each other, considered equal to each other, all or not. And so the negation operator we see here, plus we see the equity operator, plus we see the assignment operator. And let's see, are there any other operators? No, not really. Well, we have the parentheses operator here. Although they're strictly not necessary, I kind of like having them in my if statement. So if it's true that x is not equal to 1, print it is true. Otherwise, print it is false. In this case, it would print out this is true. Well, it would normally do that, but since I negated it, it's going to jump down and print out this is false. Using the not certainly works, but it can be more difficult to read, so try to use that sparingly. Another way to have written this type of code, this expression, would be to use an exclamation mark instead of the word not. So this operator is a symbol. It goes along with the equal sign, so it's a combination of those two symbols that say, is it true that something is not equal to something? So in this case, x is set to 1, and I ask the question, is it true that x, which is 1, is not equal to 1? Well, that is not true. They are equal to each other, and so it would print out false. Another one that we use all the time in the industry is the star to indicate multiplication, or a slash to indicate division. Do be aware that in many languages, the slash can either be forward or backwards, and depending on which way you put it, you may get a different outcome. So right now, I'm setting these values, and notice that I set the values to integer values, so there's no decimal point there, and yet when I print out the results, I see a decimal point. Now what I'm saying is that if in many languages, if the slash goes backwards instead of forwards, when I run this, I might expect a different result. Now in this case, it didn't do it, but in other languages, in this case, it just gave me an error message. But in other languages, what you would see happen is you would typically see an integer value. So doing a forward slash might give me a decimal value. Doing a backslash might give me an integer value. In this case, of course, I'm dividing x by y and getting myself a result, a quotient. And you might suspect that there's all the standard ones like a subtraction, in which case I get a negative, I subtract that. So I take the value of 20 and subtract 10 from it. If you have a situation, let's say I start off with 5, and I subtract 10 from it, I'll get a negative number. You can also, if you just want the absolute difference between 10 and 5, you can use the absolute function and get that. Now, at this level of class, I don't really care if you use the absolute function, but in some cases, that's an important distinction about what you're trying to accomplish. You're trying to find what the difference is between 5 and 10. Well, the difference between them, if I were to graph this out, would be 5, not negative 5. And you can use the absolute function to accomplish that. Another one that is useful is the modulo, modulo operator. The modulo operator will give us a remainder, or modulus. So if I were to do this, and run it, there is no remainder because it evenly divides 20 by 10. But let's say I go ahead and put in, I don't know, 22. Well, it'll divide 20 by 10 and have a remainder of 2. Now that's actually pretty handy for a number of things. Typically where I see it is something like this. I have 3 lines of, let's see, how do I want to do this? I have 6 lines of data. Or let's do this. I have 6 lines of data and I wanted to divide it by 2. So if I run this and it gives me back a 0, then I know that is an even row. If I get to a fifth line and I run it, I get a 1, knowing that it's an odd row. And what people will do is they'll do something kind of like this. So let's start with 6. We'll go to 5. Okay, so 6, 5, let's go 4, let's go 3. And we'll run it. And so when I do that, the first one's 0, the second one's 1, the next one's 0, the next one's 1. And what people will do sometimes is they will use those as a way of indicating whether one row is formatted a particular way or not. So for example, if I were to open up a new Excel spreadsheet and we look at it, we see a blank workbook here, we could go and say, okay, we want to format, let's see, format as a table, and we choose like this alternating style. Well, the way they're getting those alternating lines is they use code very much like what I just showed you, trying to find out whether this is an even row or that's an odd row, and then based on how it divides, they can change the color. So you can do that with all kinds of different output. And Modulo is a great way to do that. So if you wanted to have every third line, you could use a 3 and find out what the modulus was, the remainder, and then based on the modulus, you could format the output in a particular way. And as I said, we've already seen the additive operator. We can go through and add and subtract. Why don't you try putting together a script that adds two numbers together and prints out the answer on the screen. And then, of course, as always, write down what it does and make some notes about what you've learned. I'll see you back when you get done. Okay, let's talk about the lab here. So my version of the lab would look something kind of like this. Now, how you did it can be very different, but this is the way I kind of put it together. So I've made a variable called integer number 1 and integer number 2, and I assigned a value of 3 and 5. I just made up some numbers. And then I use the plus operator to add the values together, and the assignment operator to assign the results of, well, in this case, 3 plus 5 to the variable integer sum and print out the integer sum. And then I test it. Now, remember that Python will accept any type of data and automatically change the type. So in this particular case, int number 1, if I were to ask the question what type of data that is, because I put a decimal point in there, it's going to be changed over to a float. Yep, I forgot the extra parenthesis at the end here. So perhaps, since there's every chance in the world that I might want to be adding the values together with a decimal point, I might want to go ahead and make it a float. So I'll change that over. Because I'm using a very primitive tool, this editing tool, this idle tool is very, very, very simple. I might just copy and paste. I'm just using Control-C, Control-V, and copy and pasting. I do want to be careful though. See how I copy and pasted this one, and I have to change it. I didn't change this because it's a copy and paste error. And when you do your homework, that's every chance in the world you might do the same thing. So now I'm looking at this and thinking, why am I getting 7? and it's because the copy and paste error caused me to add number 1 and number 1 twice. Not really what I wanted. Hopefully you took the time to kind of mess around with the code a little bit, and if not, hopefully this little demonstration kind of helped give you some ideas about what you could have done with that lab. This next topic is about how data is treated depending on the type of data it's categorized as. So there are two basic types of categories that data can be grouped into, and they are grouped into either value types or reference types. If they are grouped as a value type, when you use operators and various things like assigning a value with the assignment operator, it actually copies the value to a variable. If, on the other hand, it's treated or behaves like a reference type, it won't copy the value, it'll copy a reference. And that's like having a shortcut that you copied. It's a little hard to explain, so let me put some work into it. Now, I will tell you this. In the documentation and things that you read, first of all, you'll find that Python tells you that everything's a reference type. But the way it behaves is either like a value type or a reference type, so that's just kind of a warning. So although the websites and documentation will say everything's a reference type, and that's true, the way it behaves is different. Now, another thing you'll see on the internet and in books is that they talk about the storage of value types and reference types as being different, and that's also true as well. The idea is that value types are stored in a different place than reference types. And if you were managing memory, if you were really specific, very clear and specific about where you wanted values, things to be, as far as in memory, that would probably have a lot more relevance to you. To me, that doesn't seem to make much difference, but I should tell you about that because you're going to read about it. In general, if it's a value type, it's stored with the core of the application that you're running, the application itself. If it is a reference type, it's typically stored separate from that in what's known as a runtime environment, or if I'm using an example from C#, that's stored in a heap. Now I am going to use an example from C# because unlike Python, in C# there's a more clear and formal distinction between value types and reference types. In Python, there's still a distinction, but officially there's only reference types, even though they behave differently. So from C#, let's say I had a variable called x, and it's an integer, and I have another variable called y, and it's a string. Now, in that language, again, it's very formally defined as far as what's a value type and what's a reference type. The x integer would be a value type. The value would be stored on the program's stack. The stack is the core area where the program is actually running, your application is running. However, the string is a reference type, and with that, it's actually stored out in this runtime, or the .NET heap, as it's called. And what happens is that with a value type, the value is actually stored in the computer's memory area. So if I had a value assigned of it of 42 to variable x, 42 would be stored right where in the memory area where the application is running. But if I were to put a string in there, what would be stored where the application is running, the spot memory where the application is running, is a reference or an address to the location where the data is actually stored. Now, if that seems confusing to you, don't worry about it too much. Nowadays, the languages that you're likely to come across and learn will automatically take care of all that for you. To me, the location of the data isn't very important. Not as important as the way it behaves when you use it. Much more important. And do keep in mind that I'm using like this as an example. So address location 123, where I've got a string called some data, is being stored within the program versus the value of 42 being stored right in the program stack. And the address 123, I just made up something like 789. You just make up a number. The computer is going to find a location in the memory chips and put it in there, and it's going to use some kind of arcane numbering scheme to identify the location in the memory chips where the data is going to be stored. So I'm going to keep it simple and just use pound and some number to indicate what's going on. Now, when I use the data, when I go through and I program to the data, depending on what type of data it is, and this is true in Python as well as other languages, it'll behave as a value type or reference type. And what I mean by that is when I use it, I will be passing a value or a reference. So again, from C#, let's say we know that integers are value types. So if I were to create a variable called x and I assign a value of 5, and I create a variable called y and I assign a value of 10, and I say x is equal to y, then we know that value of 10 is going to be pushed into the memory location of x. That's because it always goes from right to left. And the equal sign, as in Python, is the assignment operator. Now, because integers are value types, it's literally going to copy the data, the value of 10, and put it into this memory location where x was defined, where it was put in memory as 5. Originally, the value of 5 is going to be bumped out, and 10 is going to be copied over into it. That means that although x and y now both have the value of 10, they're two different locations in memory. If I were to go and change y later on, setting it from 10 to 15, that would have no impact on x because they're not interrelated anymore. They're not connected to the same memory location. They're connected to two different memory locations. So changing one does not affect the other. And that's exactly what happens when you're dealing with value types, when things behave as if you've passed over a value. But if you passed over a reference, that would be different, because if you passed over a reference, both variables would be pointing to the same location. Changing one would affect the other because they're both pointing to the same spot in memory. Think of it like a lot of people use this analogy where if you went to a post office and you saw a big wall of these little post boxes, or if you went to the gym and you saw all these lockers. You could have two people sharing the same locker. What one person puts into that locker can be accessed by the other person. And it affects both people because we're both sharing the same location. Now remember that in Python, that although all variables are reference types, they still act like value types. So if I were to put together a Python program, so I'd go ahead and define x, and it would still have to record that it's an integer. Internally it would. I wouldn't have to type that out in my code. It would actually have a little reference to some memory location. So it never stores an actual value in the program that you write, the program you're running itself. Instead, it stores the values out in the Python runtime, this shared memory space where a lot of different scripts and applications can use. However, although they do store their data in this centralized runtime environment, they still behave as these value types normally behave in other languages. So if I were to run code like this in Python, what would happen? Would it be 10 or would it be 15 when I printed out x? Well, let's find out. Let me copy this. Let's see, I want to open up that test file. Paste that in, and we'll run it. And notice that X prints out 10. Now, think about this. So X is set to 5 originally. On the second line, Y is set to 10. On the third line, though, we have said that X and Y are equal to each other. In other words, we've assigned the value of 10 to X. So assign the value of Y to X, which is 10. Now, if this had truly reacted as if it was a reference, in other words, they were pointing to the same address location, then changing one would affect the other. So when I change Y, it would change the other. But that doesn't happen. So it's true that they are stored out as a reference to your program, your script. They don't behave as if they're referencing the same location, because they're not. Now, that happens when you're using simple things like an integer. However, Python automatically changes its behavior when you're using something more complex. So in those cases, it doesn't act as if you're passing over a value. It acts as if you're passing over a reference and you're pointing to the same location. So, for example, let me just show you. Oops, that's a little bit much. Okay, so this first one, no, I'll just run the whole thing. Okay, so the first one, X is equal to 1, X is equal to Y, set X to 3, does it affect Y? No, it does not. Because although they may be stored in the runtime environment, they still act as if you passed over the value. Now let's look at this next one. In this next one, I'm using square brackets to create one of those lists I talked about. And I take the complex collection of values, the list of X, and assign it to Y. Now, if you want to access an individual member of that collection, you can do so by using a number as well. This is what's known as an index. So X0 is 1, and X1 is 2. I know that's kind of weird. Then if I had another value in here, whatever value that was, that would be 3. Actually, let me change it over to this. 4, 77. So it's 0, 1, 2, 3. How you identify individual members is by using this little index number. So what I'm saying is this. If I set 0, X sub 0, that's how you say it, X sub 0 to 3, that means that this becomes 3. What does Y print out? Notice that it prints out 3 and 2, because even though I'm printing out Y, changes to X changed Y. In other words, they're behaving as if they're both referencing the same location in memory. That's a reference. So I'm not using a copy of the data, I'm using a reference to the same data. So for complex things, Python makes a reference or acts like a reference type. For simple things, it acts as a value type. Let's look at a string of characters. So I have X, I set X to Bob, and I equate X and Y, so I should say assign. I assign X to Y. I change X to Robert when I print out Y. Notice that it doesn't change. Changing X does not change Y. they're acting as a value type. Once again, if I use strings of characters using a couple square brackets to indicate that I want a list and made the change, it would indeed change that value because it's acting as a reference. Complex data, like a list of values, acts as a reference. Simple data acts as a value. Now, in whatever language you're using, you're likely to see the same behavior. It's going to be one or the other. And if you can memorize it, fantastic. But if you can't, don't worry about it. Just know that that you need to know that this exists, and then you can test it to see what happens. So whenever you're approaching any programming language, if you're not sure what's going to happen as far as behavior of will it act as a value or a reference when I go to change something later on in my code, test it. So if in doubt, test it out. That's the mantra you really need to repeat yourself, because for me, that's the only way I can really keep track of it. I've programmed like 15 different languages, and yeah, I memorize a number of different things, but I can't always be sure unless I take the time to test it. And it's a good thing to do. So just don't worry about all the details of why it does it. Just realize that sometimes things pass as a reference and sometimes they pass as a value, and it's up to you to test. In Module 2, the demonstrations I've shown you have been using the idle integrated development environment. But I have to say, it's a pretty primitive environment. Although there are plenty of other environments that you can use, the one I'm going to be using going forward is something called PyCharm. Now, PyCharm is much more complex than idle. And I will tell you that you do not have to use PyCharm in class if you find that it's really confusing. You can continue to use idle. But I will also tell you that the sooner you get to using PyCharm, the better it will be for more complex programs that we're going to use. So you can get PyCharm by just going out and downloading it for free from the company JetBrains. So if you come over here, there's an option, download, and you want to choose the community edition. There is an education edition that you can get for being a student here at the UW, but to tell you the truth, I think there's a duration on that. For what we need, just downloading the community edition is perfectly fine. Once that's downloaded, that's yours at that point. And as you can see, it installs on Mac OS, Linux, and Windows. Now, once it's installed, you will be able to open it. Let's see, where did I put it at here? PyCharm. Oh, I didn't think I had uninstalled it. Maybe I did. Yep. Nope, I don't know why it's not showing up in there. I must be looking right at it and not seeing it. That happens sometimes. Usually I keep it right here in my development environment. Oh, right there. I thought I might be looking right at it. Now, it's taking its sweet time to open. It does that a little bit. It's much slower on opening than idle. But the way it works is I can now come over and open a file. Let's see, Python class, demo code, and test py file, and work with it. Now, there's a couple things that you'll note. First of all, there's a configuration here for that shows the line numbers. That's actually pretty handy for talking about things. Also, if I hold down the control button and roll the mouse wheel back and forth, I can zoom in and out. That's great for presentations. I will tell you one thing. Please don't do this. Don't type your code like that in real small characters, and then when you're trying to troubleshoot it, keep it small. If you have problems with your code, make sure that you zoom in nice and big while you troubleshoot. I come across students all the time trying to troubleshoot with a code really, really tiny. It makes it really difficult to do so. Now, in order for this to run this code, because it's just a text editing, tool. You need to have a Python interpreter. And what that means is that it needs to be able to send the script file over to Python for running. So I'll click on here and configure a interpreter. And I'll point to my installation of Python. And then once that is installed, then I can run my code. Now, oops, let me bring it back down here. Sorry about that. To keep the resolution easier for you guys to see on the phone, I've got my screen reduced by quite a bit here. So, okay, so to run it, I can right-click and run the entire file, and you'll see the results show up here at the bottom, which is pretty handy. I can close that. Another thing that's handy about it is I can test a block of code all by itself. In other words, I can just highlight a block of code and run only that. So let's see here. Execute selection in console. Cannot start process. Working directory is not a directory. Yeah, okay. What am I doing wrong here? Okay, well, we'll have to cut that out. So you can see the result shows up here at the bottom. Now I can close the results by just clicking on that little box and run it again. And as I'm typing in things, it kind of helps me type. So let me change this around. I'll start typing in things like print. And notice how it pops up a little help menu that helps me type in my code. So now I can either continue type in print or hit tab, and it will finish up the statement for me. And I can just type in my code and run it. And it's just helpful in a number of ways, such as if I try to put an uppercase X, see how it gives me a little red underline there? Unresolved reference. That's because this is a case-sensitive language and it needs to be lowercase x. Now there's lots of features here, such as being able to kind of slow down the program and debug it, that are going to be important to us. And the way you typically use this is not on an individual file. What I typically do is I come over and make a new project. Make a brand new project. Let's see here. Let's call it Mod02 demos. Let's use the Python 3.7 interpreter. That's fine. I create a folder, and then I add files to it. Let's see here, trying to get this to make sure that it shows up. So you can't see on the context menu, there's an option. I guess you can see it there. File new. Okay, so file, right-click, new Python file. And it makes that file. If I hover over the tab and I right-click, I can say Show in Explorer. It'll take me to the folder where that was made. This IDF folder is used by the environment to kind of do some things in the background, so you just ignore it. And the idea is that for my homework, etc., I would like go through and make a new folder. Now we're not going to need to do it on assignment 2, but for assignment 3, I'd probably want to go ahead and use it. And I'd put my assignment file in there. Let's see, I can't remember what assignment 3 is, but let's say we're doing file processing. And then we put in whatever code that we're trying to accomplish. And then the idea would be that you'd test it and work with it and save your work. And then when you're done, you'd right-click on the folder, show in Explorer, and you'd zip that entire folder up and send it off for grading up on the Canvas site. So for Module 2, you can just keep using idle. But in Module 3, we're going to switch over to using PyCharm. I'm going to give you some links that I'd like you to go out and take a look at. I want you to download the tool and try to play with it a little bit. Even if you don't end up using it, just kind of get ahead of the game. Also, there'll be a link to a video, a little tutorial that kind of walks you through the process of using this tool. Now, we're not going to get into anything fancy. This tool can do a lot of fancy things, but I think that once you get used to using it, although it is more complex, you really won't want to go back. So go ahead and focus on getting your homework done as is with the tools you have, because you got enough on your plate right now. But as soon as you kind of get that straightened out, when you're feeling a little bit more adventurous, go out and learn a little bit more about PyCharm. I think you'll find it was well worth your time. So that's it for Module 2. Module 2, we looked at what is a variable and what is a constant, what value types are, and reference types, and what is a data type. What I'd like you to do now is continue with your studies. So I've given you a pretty good overview of the topics in Module 2. There's still more to learn. There's always more to learn. And you'll do so by reading through the internet links, you're watching the videos. If you're using a book, reading the chapter in the book assigned. And see if you can answer these questions from memory. Think about being in an interview or talking to a coworker and they ask you these questions. Could you articulate what a variable is, or what is a constant, or how you assign a value to a variable? What is an overloaded operator? Look at these questions, get it down to a point where you could answer these questions from memory, and you will have accomplished the core of what we need in Module 2 before we can move on to Module 3. And I'll see you there.